Hello, this is Mr. Collier, and today we'll be talking about function notation. So in this first example here, this is actually in function mapping notation, and we can write this as f of x equals 2x plus 3. It means the same thing as that, or you can write it as y equals 2x plus 3. So it's a linear equation, y equals 2x plus 3. Okay, so we're going to use this form of function notation in our problems today. So in this first example, let's just change this to our f of x function notation. So we have f of x equals 2x squared minus 3x. And it asks us to find f of 5 and f of negative 4. So for the first part, when we find f of 5, that means wherever you see the x value, you put in the value of 5. So we're going to substitute that in and work that out. That's 2 times 25 minus 15, which is 50 minus 15, which equals 35. So f of 5 equals 35. And another way to say that is you can say that when x is 5, the y value is 35. So if you were to graph this function, you would see that the point 5, 35 is on the line. Okay, in a different color here, I'm going to do part B. So we have f of negative 4, so f of negative 4, and we do 2 times negative 4 squared minus 3 times 4. And so you get f of negative 4. Now negative 4 squared is 16. 2 times 16 is 32. 3 times 4 is 12. So you're going to subtract 12. And you get f of negative 4 equals 20. And again, another way to say that is that if the x value is negative 4, the y value is 20. So that point would be on this particular line. Okay, let's look at the next function. We have f of x equals 5 minus x squared minus x squared. So let's do part A. F of negative x, and this time we have a variable in here, so we're going to, wherever we see x, we're going to put in negative x. So here we're going to put in negative x, and here we're going to substitute in the value negative x, and then simplify. So we're going to have now negative x is going to be plus x. Then we have minus negative x squared. Well, if you square something, you always get a positive value, so that's going to be positive x squared. Okay, so we actually get the same function back when we substitute in negative x. Oh, actually it's slightly different. So we have a plus x here. So we have a slightly different function. And part B, we're going to substitute in x plus 2. So f of x plus 2 equals 5 minus x plus 2 minus x plus 2 squared. Okay, so we're going to have now 5 minus x minus 2. You can distribute the negative sign, and we're going to have 5 minus x minus 2. And over here, x plus 2 squared, we can rewrite that as x plus 2 times x plus 2. Okay, now over here, let's start simplifying here. We have 5 minus 2. We get 3, and the negative x stays there. And let's do x plus 2 times x plus 2. We can do the FOIL method and do x times x times 2, 2 times x, and 2 times 2. And we get x squared plus 2x plus 2x plus 4. And let's simplify some more here. 3 minus x squared plus 4x plus 4. And here we're going to distribute that negative sign. So this becomes negative x squared, negative 4x, and negative 4. So let's do that here. So we're going to have 3 minus x squared minus 4x minus 4. And we can match up the like terms now. We have 3 and negative 4. That gives us negative 1. We have negative x and negative 4x. That gives us negative 5x. And we have negative x squared. So here we have f of x plus 2 equals this function. Okay, next, main thing we want to look at here is this mapping diagram, which we're going to do in a second. So each member of the domain maps to a member or more than one member of the range. So it's important to remember that in the mapping diagram you have basically you're going from domain to range and listing all the values in the domain and range and drawing an arrow to show which ones match. So we're going to be doing that in a second. Okay, so here this function is just same as f of x equals x squared or y equals x squared, and we're given a bunch of domain values, and we have to basically find the range values. So we have 5 values in the domain, and we're going to find the 5 values that correspond with that domain, and we can do one at a time. Actually, I'm going to do it both ways here. So let's do it this way first. So the domain is negative 2, negative 1, 0, 1, and 2. Now your range, you're going to have 5 values corresponding to those. So your function is f of x equals x squared. So we just need to square each of these values. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So this is our range right here. And I'm going to show how to do that on the graphing calculator as well. It might help for a more complicated example. So what we can do is we can type in the function y equals x squared. So if we do that, and then we can go to table, so second function graph. And here's our table, so you can see all the values for all of these x values here. Now notice that this does not include the negative x values. So what you can do is actually go to second function, table set, and you can start at a different value. And we don't have to start at 0. We can start at negative 2, like right here. We want to start at negative 2, so I'm going to put that in as negative 2, and then go to second function, table. And here we go, we have our first 5 values here. That's basically our answer. So our range is over here. We have 4, 1, 0, 4, 1, which is what we have right here. So actually, let's do in part B. Part B, do that in a different color. Part B, we're going to represent this function with a mapping diagram. So we can draw a blob here for our domain values, and actually I'm going to make that a bit bigger. I don't think I made that big enough. So here's our domain values of negative 2, negative 1, 0, 1, and 2. Okay, and we can call these the x values. We call these values over here the f of x values, or we call it x squared. So we have that, and the range values are 4, 1, 0, 1, 4. And we can draw an arrow to indicate that negative 2 maps to 4, negative 1 maps to 1, 0 maps to 0. So basically when you put in the x value of 1, you get 1 back, and 2 gives you 4, and so forth. So there's your mapping diagram. If you look at the graphing calculator, it looks exactly the same. You could actually just draw a blob around the first 5 values here and blob around the first 5 values, and it's exactly the same values as we have in the mapping diagram. Okay? and show this information on a set of axes. Okay, we've already got it in our graphing calculator. So we can actually, oops, that's actually not going to work because we want just these 1, 2, 3, 4, 5 points. So we can make a sketch of that right now. Let's just do a sketch. Oops, I wanted a red color for that. So let's do a sketch. And here's X and Y. We have, let's do that in a different color. We have 0 maps to 0. We have 1 maps to 1. So we can go to, let's do a little scale here. Okay, so we have 0, 0. We have 1, 1. We have 2 maps to 4. So the X value is 2. Then the Y value is 4. When we have negative 1, we have 1. When we have negative 2 for X, it maps to 4. So we get 4 up here. So those are your 5 points on an X on a set of axes. Okay, in this next one, we have here this function. Let me rewrite that as f of x equals positive or negative root x. Okay, that means your answers are going to have 2 different values, or your x values are going to map to 2 different values. So find the possible set of elements for the range. Okay, so let's start off with the domain. Let's stay in green. Let's start off with the domain. The domain is 0, 1, 4, 9. Now for the range, let's see what values we get. If we take the square root of 0, we get 0. Okay? Positive 0 is 0, negative 0 is 0, same thing. But if we get the square root of 1, we have 2 possible values now. We have negative 1 and 1. Alright, now if we take the square root of 4, we get 2. But because it says positive or negative square root of 4, then we get positive, well, let's start with the negative 2 and then positive 2. Negative 2 and positive 2. Don't need the positive, that's okay. Square root of 9 is 3, so you get negative 3 and positive 3. So in this case, your range is a lot bigger than your domain. So let's see what the mapping diagram looks like. So the mapping diagram, you've got 0, 1, 4, 9. And your range is going to be a bit bigger, so let me just draw that a little bit bigger to make some room. So we have 0, we have negative 1, 1, we have negative 2, 2, negative 3, 3, and then I'm going to do the mapping part. So 0 maps to 0, 1 maps to negative 1 and to 1, 4 maps to negative 2 and to 2, 9 maps to negative 3 and to 3. So that's what it looks like. You can write x here, and you can write maybe even at the arrow to f of x, or you can write in the function positive negative root x. So that's your mapping diagram for that one. And it says show this information on a set of axes. So again, we can plot those points. Let me do that right here. Okay. So our x values go from 1 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Our y values go from negative 3 to 3. So 1, 2, 3, 1, 2, 3. And so we have 0, 0. We have 1 negative 1 and 1 positive 1. We have 4. 1, 2, 3, 4. 4 maps to negative 2 and 2. And 9, all the way over here, maps to negative 3 and 3. So it looks like if you were to connect the dots, you'd get a sideways parabola there. Okay, now last example. Let's write that down here in set notation. So in A, your domain would be all these numbers here, and you can even write them in order. Don't have to, I guess, but -2, -1, 0, 1, and 2. Actually, writing them in order might help us out for the next part. The range is -7, -4, -1, 2, and 5. Okay, in part B, find the equation of the function. So let's look at the function and the difference of the values in the range. So if you look at the range, the values are going up by 3 each time. So that means when you have your equation, you're definitely going to have a 3x here, because that's your rate of change of the x values. And let's figure out what the other part is, what the y-intercept is. It's going to be plus or minus some number. The key is to look at this number right here, and you can figure that out. If the x value is 0, then you want to get a -1 value for your y value, then this has to be a -1. Okay, so then if you put in 0, you'll get a -1 value for y, just like it shows us in the set notation for domain and range. Okay, you could also rewrite this as f of x equals 3x minus 1, and we can check our answer over here by trying some values. So if we take f of 2, for example, we get 3 times 2 minus 1, which equals 6 minus 1, which equals 5. And we do have a 2, 5 in the domain and range, so it looks like it's working.